Okay, we are going through the topic of level of service and capacity. And up till now, we have talked about what is capacity, what is level of service, and how many levels of service we have, and what do we mean if we have level of service A and B and C and D, then what type of traffic we can expect. Still sleeping? Okay. Now today we will look at how we find out the level of service. We'll start with it. Okay. So I told you we are doing for now multi-lane highways and freeways. Okay. We are doing for now multi-lane highways and freeways. Okay. This is the graph which we require for both of them. Okay. This is the graph which we require for both of them. This is the graph you have to plot in your term projects as well. Okay. This is the graph you have to plot in your term projects as well. And this is the graph which gives me most of the students from the previous semesters. Okay. So when we are facing problem, okay, we will have students in the next semester or not, I'll give them this graph in the final exam. What? But not now, already said it. Not now. Yeah, they made these type of faces last semester when this graph came in the final exam. Okay. But you had a chance to do it earlier, right? A graph came in exam 1.
What about this exam?
Sorry?
We will get it in this exam?
No.
This too,
What?
This too.
Yes, true. Yes. Okay. On the x-axis, flow rate. On the y-axis, speed. The behavior of the graph shows you what we have already explained. Initially, flow rate increases, speed nothing. Okay. Then we reach a point where we start to see the decrease in speed. That point is called the breakpoint. Okay. In the graph, it is called the breakpoint. Earlier we called it practical capacity. Okay. So breakpoint, practical capacity means the same thing. Point after which the speed starts to go down. Okay. Now you can see the graph is up to a point. After that point, the graph is finished. Okay. It's cut off. That point is called what? What is the last point called? Capacity. Okay. After capacity, now this is the graph for flow rate, right? Flow rate is increasing. Flow rate is going up. Okay. So now you can imagine why at capacity the flow rate has suddenly vanished. Because after capacity, what do we have? We don't have flow rate increasing. We have flow rate decreasing actually. Okay. So this graph goes up to capacity, after which it will go down towards 0, which we don't need. Got it? Clear? Okay. Now if you have to plot the first part of the graph, the line, okay, you only need one value, right? What is the speed? That's it. You will draw a line, okay, and you need the end point. Okay, what are we calling the end point? Breakpoint. Okay. So for breakpoint we have an equation. Okay. For breakpoint we have an equation. And this speed is which is speed? FFS. FFS is what? Free flow speed. Okay. So how to find out the free flow speed? We do a study, which I asked you to do for your term projects as well. Which study? Which study did you do in the second part?
The mean.
Yeah.
A volume.
Mean of what?
Speed.
Speed, right? Which is speed? It's a specific speed. Free flow speed. Huh?
Speed.
It's the name of a topic which we have covered. We do that study to find out free flow speed. Spot speed. Okay? So free flow speed comes from spot speed, but we have an equation for that as well. So you have an equation for this, you have an equation for this, and you can do a study for this as well. Okay? Now, this is a curve. Okay? So curve means what? Every point x and y is changing, right? Every point x and y is changing. Okay? What is my x? Flow rate. What is my y? Speed. So I need an equation between flow rate and speed, right? This is a equation. Okay? So when I cross the breakpoint, see this equation is when you are crossing the breakpoint. Before the breakpoint, it's just a value. Alright? This value. Clear? after the breakpoint, we have to apply this equation. Free flow speed, you know. C is capacity. C means capacity. Okay. DC means critical density. DC is critical density. This density. And this density is where? At this point. And what is this point? Capacity. This is the definition of critical density. Density at what? Capacity. Right? So you can see in the graph it has a value. From where did we take the value? We have, I will show you. Okay. This value is, for our purpose, it's fixed. For the purpose of our calculation, it is fixed. Okay. What else do I have? What is BP? Blood pressure, right? Blood pressure. What? No, what? Then what? Breakpoint. Okay. Anything else? VP is the flow rate, C is capacity, BP is breakpoint, DC is critical density, and speed, whatever you find. Okay, clear? There. Okay. Where are the equations? These are the equations. A nice table which has equations for freeways and multilane highways both. Okay. Now you don't see the equation for free flow speed here, but they are telling you that you can measure it, you can do a study, or you can predict it using equation. Equations we will see later. You can do it in both cases. Okay. Capacity, you see the equations for capacity. Okay. Now there are factors here. You can see. For the time being, I'm skipping over these factors. Okay. This factor and this one. Okay. I'm skipping. I will come back to it. Okay. So we have the equation for capacity, and that equation needs what? If I want to calculate capacity, I'll put what here? Free flow speed. Anything else? No. Okay. Now free flow speed for each case has a range. Okay, which I mentioned in the last lecture as well. Okay, if you are dealing with a freeway, its speed should be in this range. Less than this is not called a freeway. Okay, so dealing with multilane highway, this is the range. Okay, clear or not? Accordingly, capacity also has a range. Capacity of freeway should be this value or less. For multilane highway, this value or less. Clear? Now what if the equation gives you here 2400? Then what do I do? For multilane highway, I use the equation, I get answer 2400. And this says it should be 2300 or less. What should I do? Huh? We already calculated. Now the answer is more than this. What should I do? I take what? 2300. Okay. So the equation only works up to here. Equation only works up to here. After this is the value. Okay. So I need free flow speed. You can do the study or you can calculate it. I need capacity. These are the equations. And I need breakpoint, right? I need breakpoint. So breakpoint for multilane highways. Again, what do I need? Free flow speed and this factor which we are not studying right now. For multilane highway, very easy. This is the value. Doesn't change. Clear? Okay. Now you see the last is A value. What is A? A is in this equation. Okay? Clear? So in this equation, I need breakpoint. I showed you the equation and the value for breakpoint. I need capacity. I showed you the equation for capacity. Okay? I need free flow speed. You can measure it, you can calculate it. And I need the A value. A value is given. Clear? Okay? So to use this equation, I need that table to calculate or find out the values. Okay? Any questions? Okay. These are some of the graphs which are plotted for fixed values. So they assumed some values of free flow speed and A and everything, and they plotted these graphs. Okay? You have to plot a graph like this for your highway in the template. Okay? So this starts with free flow speed, right? The starting point is what? Free flow speed. Okay. And what point is this? Breakpoint. Okay. From here to here, how do I get the point? I have to use the equation. Clear? Okay. We will do an example where I will show you how to use the equation in more details. Okay. Right now, we are looking at this graph. I can see the free flow speed. I can see flow rate and speed. And then I see these lines as well. Okay. And within these lines, I see, what is this? Level of service. Okay. So within these lines, I see the level of service. Each line represents a density. Okay. I told you earlier, this method of calculating level of service comes from highway capacity manual. The manual has fixed density for each level of service. Okay. There is a range of density which is fixed for each level of service. For level of service A, the range, and for freeway, for each type of highway, the range is different or could be different. It's the same. Okay. Anyways, but the other things are different, so the graph will be different. Okay. But the range is same. So for level of service A, it starts from 0 up to 11. Okay. For B, from 11 up to 18. For C, from 18 up to 26. Okay. Now, how do I plot these lines? These values of density give me the slope of these lines. Now, if you have to plot a line, you need a point and a slope, right? You can plot a line using a point and a slope. What is my point? So I just need the slope, right? Okay. What is my slope? These values. Okay. Why? Density equals flow rate upon speed. Density equals flow rate upon speed. Okay. Clear? Do I have flow rate here in the graph? Do I have speed here in the graph? Can I do flow rate upon speed? And if I do flow rate upon speed, will be the slope of the graph? If I do flow rate upon speed, will be the slope of the graph? Okay, so this is how we plotted the lines. We use the density and we said, okay, this is my tangent theta. Flow rate upon speed. Okay, and we draw the line according to that. Clear or not? Okay, I'm just giving you the concept. We haven't done any examples here. We will do each other. Okay. So you use the densities of each level of service which are given in the manual, and you take them as the slope and you plot these lines, and wherever these lines are going, you know this is the level of service. Okay, clear? Okay. This was for multi and high, sorry, this is for freeways, and this one is for multi and highways. Okay, so what is the change between a freeway and the multi-lane highway? The capacity equation is different, the breakpoint is different, the A value is different. Okay, and the range of free flow speed is also different. Here you can see free flow speed starts from how much? 75 goes up to 55. Here it is lower, from 60 to something. Okay, so the values are different, but you can see the shape is still the same, and the lines are still same slope, right? Same values for the lines. Okay. Okay. This is what is given in the highway capacity manual, the first table, the first one. Okay, so you can see the range for each level of service. This is the range of density I was talking about. Okay, and what is the last value here in the table? What is the last value of density? $45, right? Okay. Okay. This is how we fixed it. Okay. According to the range of level of service. Okay. The last value of level of service E is 45. So this becomes my critical density. Density at capacity. Okay. Okay. Now this is something different. Okay, it is taken from the old manual. I haven't found it in the new manual. I did not even find it in the old manual. They are using in the market, in the consultancy, they are using it. Okay, somehow. Okay, but here instead of density, they are saying level of service is according to V by C ratio. V means flow rate, C means capacity. Flow rate upon capacity. Okay, so if your flow rate upon capacity is between 0 and 0.3, your level of service is A. Okay, if it is more than 0.3 up to 0.45, it is B, and so on. Okay, but I did not find this type of table in the manual. Okay, this is from somewhere, somebody from the industry. Okay, something which I mentioned earlier as well, every level of service has a maximum flow rate. You can see it's a line, right? Level of service A is up to this line, right? Level of service A is up to this line. Okay, so you can see the line is intersecting the curve at a particular point. Okay, at this point I can go to the x-axis and see what is the flow rate. That flow rate is the maximum for A, right? Because after this the line of A is not there. Get my point? Okay, this is the line of A, right? This is the line of A. If I go above it, then I'm not at level of service A, right? So if I draw a line from here and I get this flow rate, when I'm on this side of the line, when I'm above the line, my flow rate will be more than this, right? Will my level of service be A? No, it will be something else, right? Okay. So wherever the line intersects the curve, this is the maximum flow rate for this level of service. Okay. So what are these values? These are the intersection points of these lines for each curve. Okay. So these values for level of service A, right? So intersection points of this line. Okay. These values for level of service B. So intersection point of the line of B. Got it? Clear? Everybody? Okay. So this curve is for freeways, okay, and this one is for multilane highways. Okay, this is taken from the curves of multilane highways. The previous one was taken from the curves of freeways. Okay, I said you have to plot these curves, right? You have to plot this curve for your highway, right? The highway which you have taken in your project. Why do we plot it if I have it? Why should I plot it? Yeah, I want to make your life miserable, but why like this? I'm asking you to plot it if you already have it. This is a curve, right? So if I already have the curve with the line and the maximum surface flow rate and everything, why I'm asking you to plot it?
Flow.
Because of flow. It is for all the flows, right? From 0 to whatever. From 0 to capacity. Yes? Because of the speed. Which is speed?
The road speed.
Which is speed of the road? Average speed, free flow speed, minimum speed, maximum speed, 85th percentile speed. Which is speed? Half correct. But which is speed? Free flow speed. Yes. To use these curves, the free flow speed should match. Okay? To use these curves, the free flow speed should match. If you are in Pakistan, it would match. Okay, but now you already showed it to me, right? So, I know it's different. So, some students did that, by the way. Not with the speed, with something else. They told me, doctor, show us a graph. Show them the graph. They came after 5 minutes, this is our graph. Same. Okay. People from Pakistan. You guys cannot do it. Don't try. You waste your time. You are nice people. Nice and honest, right? Okay. So the free flow speed should match, otherwise this curve is not usable. Interpolation does not work because it's a curve. Interpolation does not work because it's a curve. Interpolation basically is for straight lines. Interpolation is for straight lines. Okay. So yes, a part of the curve is a line, but then it becomes a curve. Okay, both of them should match, right? You cannot do interpolation for half of the curve or half of the graph. Okay, so that's why we don't do it. Okay, so I said there are factors which are mentioned in this table. Okay, SAF and CF. SAF, so now you have the picture, right? How to draw the graph minimum. Okay. Before you start using free flow speed and capacity, you have to see if any adjustment is required on these values. Okay. Whenever you go on plotting the graph, so you need free flow speed, you need capacity. Okay. Before you start, so these values can come from here. Before you start using these values for the graph, you have to see that if I need any adjustment for these values or not. Can I use these values as it is? Or should I apply any adjustment factor? Okay. So that's why we have the adjustment factor, SAF, speed adjustment factor, and CF is capacity adjustment factor. So one of them applies to speed, the other one applies to capacity. Okay, and not any speed or free flow speed. The first one is for free flow speed. Okay, and you can see it is mentioned in the graph as well. Okay, which factors we are talking about, which adjustments we are talking about? These are 4 conditions because of which adjustment could be required in speed or capacity or both. Okay, 4 conditions because of which you may need adjustment in speed or adjustment in capacity or both of them. Okay, what are these conditions? The first one is good weather. Okay, so these are the ideal conditions. If you don't achieve them, then adjustment is required. Okay, so they are listing down the conditions which are considered as ideal. If you don't reach them, then adjustment is required. Okay, the first condition is good weather. What is good weather? This. You may not like it, but it is good. The second condition is having any incidents or accidents in on the road. Okay, having any incidents or accidents on the road. Okay, accidents, we know accidents, right? Incident could be a check post, a barrier or something like this. Okay. Work zone, no work zone. What is the work zone? Any construction or maintenance activity happening on the road or close to the road. Any construction maintenance activity happening on the road or close to the road. Okay. If it is on the shoulder or on the sidewalk, it's still considered as a work zone. Okay, because it's too close. Okay. Then the last condition is about the drivers, the motorists or the drivers. All drivers are familiar or regular users. Okay, all drivers are familiar or regular users. These are considered ideal. If you do not meet any of these ideal conditions, an adjustment would be required. Okay. Now we will apply the adjustment on 2 things: speed and capacity. Okay. So which condition will affect which one of them? It is given or mentioned in this table. Okay. So the weather condition affects speed as well as capacity, both. But if you look at incident, it only affects what? Capacity. Nothing for speed. Got it? Okay. So if you don't meet this condition, you only have to change your capacity. Nothing on the speed. But if you don't meet this one or this one on this one, then it will change speed and capacity both. Clear? Okay. So it may happen that you have a work zone and you are living in Canada, so the weather is not good. Okay, it can happen, right? So you may have two factors for speed and 2 factors for capacity, because you are not meeting 2 conditions, right? Okay, so you have 2 factors for speed, 2 factors for capacity. You can have 3 factors for speed, 3 for capacity. It can happen, right? Okay, or you can have 4 for capacity and 3 for speed. Okay, you can have more than one condition not met. In the end, we have to combine these multiple factors into one variable. For each variable, we will combine these multiple values into one. So for capacity, if I have 2 or 3 or 4 factors, I'll combine them into one. If for speed I have 1 or 2 or 3 factors, I'll combine them into one. How do we combine them? We simply take the product. Okay, if you have 3 factors, you will multiply all 3 of them. Okay, if you have 2 factors, you will multiply 2 of them. Okay, if you have 1, you will multiply. Okay, so all the factors which are available must be multiplied. All the factors which are applied must be multiplied, but you cannot multiply speed with capacity. All factors of capacity can be multiplied together, and all factors of speed can be multiplied together. Okay. Table. So out of the 4 conditions, for 3 conditions, our life is very easy. There are factors available in the table. Okay. So this is the factor for table of weather. Factor of weather for capacity. Okay, CF. Okay, weather condition is mentioned. The numeric value of that condition is mentioned. The factor is mentioned. Okay, so say medium rain. Medium rain means what? For us, 10 drops. For Malaysia, it's like the whole day is medium rain. Okay, so that's why the value. That's why we have the value. Okay, so if you are confused with what do they mean by medium and high and whatnot, you can look at the value and you can measure. These values are measured. Okay, so you go to the table and you find out the capacity resistance factor. This is for weather and capacity. This is for weather and speed. Alright. Okay. This is for incidents. Okay. And this is only for what? Is only for capacity. Okay. There is nothing for speed. For incident. Okay. Yeah. If there is an incident, we will look at this. The same thing for work zone as well. You have to see how much of the road is affected by the incident. Okay. Is the shoulder only affected? Is only one lane affected? Is only two lanes affected? And so on. So the factor is according to how much part of the road is affected by the incident or the accident. Okay. So if it's an accident, maybe only one lane is blocked. Okay. Or they put the car on the shoulder, so the only part blocked is the shoulder. Okay, and the rest of the road is free. So you take the factor according to that. Okay, and some of the values are, you can see, NA. NA stands for what? NA is what?
Non-applicable.
Non-applicable. Okay. So why these values are not applicable? Why 4-lane close is not applicable?
Cannot be predicted.
Cannot be predicted.
Because the number of lanes is already too high.
The number of lanes is already too. How can you have 4 lanes blocked?
The number of lanes is what? What is it?
There are 2 lanes, right?
Yeah.
In the first row. So how can you have 4 lanes closed?
So you close the whole highway.
Yeah.
Okay.
Whatever makes you happy.
It's making me happy.
Huh?
Makes me happy. Yeah.
This is for the condition of the familiarity of the drivers. Okay. So we have again factors for both cases, both parameters, speed and capacity. The first one is the ideal case, all drivers are familiar. Second one is most of them are familiar, and then most of them means more than 50% are familiar. Okay. Then we have balanced, 50 know this, 50 don't know. Okay. More than 50% don't know, mostly unfamiliar. All are unfamiliar. A road on Mars. Nobody knows about it. You go there for the first time. Yes. You go there, yes. And we still be using these factors here, right? Okay. Okay, this will require a lot of explanation in the example as well. I will stop it here. Okay, so today we have looked at the speed flow curve. We have looked at the speed flow curve and how to plot it. We need the free flow speed to start. Then you need the breakpoint to know where to go down. And then you need the equation to plot the curve, the last part of the curve. Okay, and the curve only goes up to capacity. Okay, and then how do we plot the curve? The equations which we need are given here. Equation for capacity, equation for breakpoint, and the constants. If the breakpoint is a constant, it's given here. If the a value is a constant, it's given here. Okay, and some of the curves which are already plotted using this methodology. The reason for showing these curves was to give you the concept of level of service lines. Okay, so these lines are plotted according to density, and density becomes slope in this graph. So density is loaded upon speed. Okay, these are the values from the highway capacity manual, the fixed values of density, and another approach which uses volume upon capacity ratio. Okay, the intersection point of each line becomes the maximum flow rate, okay, called as service flow rate, and it's also given here, okay, for the plotted curves for multi-average and freeways both. Then the conditions which require you to apply the adjustment factor is applied to free flow speed and capacity. Okay, when do we apply it? When we don't meet these four conditions, any of them. Okay, if there are more than one conditions not met, you will take their factors and multiply them to make them into 1. Okay, and all of them affect capacity and 3 of them affect speed. Which 3? The ones for which I have showed you the, no sorry, which 3? Whether, okay, incident only affects capacity. Then we have driver familiar, not familiar. This affects both of them. And the fourth one, which we need to calculate, we will do it after this inshallah, is the work zone. Okay, what was the work zone? What is the work zone?
Construction of antennas.
Where? In my house.
Or near the.
On or near the. Okay, clear? Any questions?